feel like we should be able to solve for x somehow. So let's explore one possible approach and see where it leads us. A common strategy in algebra is to apply the same operation to both sides of an equation. Here, let's try squaring both sides. Whatever we do to one side, we must do to the other. So when we square both sides, we get the quantity x plus 10 all squared equals x squared. Now we need to expand that squared expression on the left. To do that, we'll use the perfect square formula. A plus b all squared equals a squared plus 2 times a times b plus b squared. We apply that formula directly to x plus 10, so we write x squared plus 2 times x times 10 plus 10 squared equals x squared. Now let's simplify each part carefully. 2 times x times 10 becomes 20x. 10 squared equals 100. So now our equation looks like x squared plus 20x plus 100 equals x squared. Next, we want everything on one side of the equation so we can compare terms. We subtract x squared from both sides. That gives us x squared plus 20x plus 100 minus x squared equals 0. Now, notice something helpful. We have a positive x squared and a negative x squared. Those cancel each other out completely. They're exact opposites. After canceling them, we're left with a much simpler equation. 20x plus 100 equals 0. Now we solve for x. First, subtract 100 from both sides. 20x equals negative 100. Then divide both sides by 20. X equals negative 100 divided by 20. We can simplify that. Remove a 0 from top and bottom. Negative 10 divided by 2 equals negative 5. So we get x equals negative 5. But here is the really important part. Whenever we change an equation in a big way, like squaring both sides, we must check the solution in the original equation. Squaring can sometimes introduce answers that don't actually work. So let's check. Our original equation is x plus 10 equals x. Substitute negative 5 for x. That gives us negative 5 plus 10. Does that equal negative 5? Negative 5 plus 10 equals positive 5. So we are comparing 5 equals negative 5. That is not true. Since the statement is false, negative 5 is not a valid solution. It appeared during our work, but it doesn't actually satisfy the original equation. This is called an extraneous result, an answer that shows up during solving but doesn't actually work. So after checking, we conclude there is no solution. Now, let's quickly see a more direct approach that reaches the same conclusion. Start again from the original equation, x plus 10 equals x. Instead of squaring anything, subtract x from both sides. That gives x plus 10 minus x equals 0. The positive x and negative x cancel out. We're left with 10 equals 0, and that is clearly not true. So this confirms our earlier result. There is no value of x that makes the original equation true. And that's the real lesson here. Algebra isn't just about manipulating symbols. It's about checking whether the result actually makes sense in the original statement. Thanks for working through this with me. And remember, always check your solutions, especially when you square both sides of an equation.